Hi everyone, this is my YouTube channel Priyanka Tutorials. In the last video, I have given you basic idea about the approximation methods of solution of algebraic and transcendental equations. I have told you three methods: bisection method, regular Falsi method, and Newton-Raphson method. And I have told you in the last video some basic idea or basic condition to solve any equation by bisection method. In this video, I will solve an equation with the help of bisection method. Suppose my question is find the root of the equation x cube minus x minus 1 equal to 0 lying between 1 and 2 by using bisection method. So in this example, I have to find the solution of this equation with the help of bisection method, and interval is 1 to 2. So as we can see, this function is continuous in this domain. So let's start from the condition of bisection method. That was that first I need to check value of fx at end points of the domain. So what will be the value of 1? It will be 1 minus 1 minus 1 is minus 1, that is negative. What is the value of 2? It will be 8 minus 2 minus 1. It will be 5, which is positive. Hence you can see that f into 1 into f of 1 into f of 2 less than 0. That means at least one solution of fx will lie in the domain 1 and 2. Now what will be that solution? That will be first approximated solution and will obtain by like this. So value will be 1.5 of that first approximated root. Now we will find second approximated root. For that we will need to find that approximated root x2 will lie in which interval. Now I have two intervals like this. I have subdivided this domain 1 to 2 into two subdomains, 1 to 1.5 and second is 1.5 to 2. Now I need to see that my second approximated root will lie in this interval or in this interval. So we will check from this property. So for that I need to calculate the value of 1.5. So its value will be 1.5 cube minus 1.5 minus 1, and hence its value will be 0.875, which is positive. So from here I can see value of f1 is negative 1 and value of 1.5 is 0.875, that is positive, and value of f2 is also positive. Hence in this interval 1.5 to 2 solution can't exist. So solution will exist in the first interval 1 to 0.5. So my next second approximated root will be 1 plus 1.5 by 2. Hence its value will be 1.25. This is my second approximated root and it will lie in interval 1 to 1.5. Clear? Now I need to see value of this root. So its value will be, according to given equation, its value will be minus 1. So after solving this I will get negative of 0.297, which is less than 0. So now I can see this value is negative and value at 1.5, that is positive. Hence my third approximated root will lie between, it will be like this, 1.5. So third approximate root will lie in this interval because value of f1 is itself negative, and for the same root solution can't exist. So my third approximate root will lie in interval 1.25 to 1.5. 5. So what will be my third approximated root? F3 will be 1.25 plus 1.5 by 2. So its value will be 1.375. So I need to repeat this process until I didn't get these approximated roots either at most equal or after doing some round off somehow equal, until I have to do this process. So again I need to calculate value f of 1.375. its value will be, according to given equation, its value will be 0.2246, which is positive. Clear? So now this value is positive, value of 1.375. so my domain will be 1.25, 1.375 and 1.5. so I need to check where my root will lie, either in this interval or in this interval. So here I can see value of function f at 1.25. its value is negative. At point 1.375 it's positive, and at point 1.5 its value is positive. So positive and negative. Clear? So my root will lie in this interval. Clear? So root will lie interval 1.25 and 1.375. Clear? Okay, so my fourth approximated root will be 1.25 plus 1.375 by 2. What will be its value? After solving this, my value will be 1.313. Clear? See, this root and 1.375, it is somehow equal but not completely after doing round off also. So I need to calculate 2 to 3 steps more. So now I need to calculate value of f4. So its value will be according to given condition plus 1.3, sorry, it's minus 3 minus 1. Hence its value will be minus 0.0494. it is less than 0, as you can see. So again we need to calculate. My interval was 1.25, 1.313 and 1.375. So I need to calculate either in this interval root will lie or in this interval. As value of function at point 1.25, see, it's negative. At 1.313 value is negative, hence can't lie in this interval, so definitely will lie in this interval. So what will be our fifth approximated root? It will be by 2. So its value will be 1.344. I have to repeat the same process. So what will be the value of 1.344? It will be whole cube minus 1.344 minus 1. Its value is positive and is 0.0837. Clear? It is positive. So now again I need to show where my root will lie. Sixth approximated root. So interval will be now 1.313, and I need to see where this root will lie between this interval. 1.344 and 1.375. Now we will see between these intervals. Value of function at this point 313 is negative. At point 1.44 positive, and 1.375. See, its value is positive. Hence, root can't lie in this interval. So, root will lie within this interval. So, sixth approximated root will be by 2, and its value will be, it's the sixth approximated root. Its value is 1.329. After doing the same process on the 8th iteration, I will get the 8th approximated root 1.325. It is equal up to 2 decimal points. Hence, the iterated root or the approximated solution of this equation will be x equal to 1.32. Like this, we will calculate approximated root of this equation. These questions are somehow lengthy, but in the examination you will use scientific calculator. With the help of scientific calculator, it becomes very easy to solve, very easy to calculate. So this was the procedure how we find approximated solution of any equation with the help of bisection method.